Hi everybody, what's up? So this is a lesson about special products. So there's about three different kind of concepts within this lesson, and I am assuming you've done the multiplying FOIL things, like multiplying the binomial times binomial lessons from 2 weeks ago. Okay, so the first weird thing is, well, what if you have something like this? You have a binomial squared. Okay, so squaring a binomial means the binomial times itself. Okay, so this all means, this, just so you understand, this means x minus 3 times x minus 3. Okay, so that's what this means. So what would be x minus 3 squared? Well, x times x is x squared. X times negative 3 is negative 3x. Negative 3 times x is negative 3x. And then negative 3 times negative 3 is positive 9. Wow, I can't write today. Alright, so that's x squared minus 3x plus 9. Okay, and then you have to combine like terms in the middle. You get x squared minus 6x plus 9. Hope your writing is better than mine. Okay. That rhymed. Alright, so yeah, so that's what it means. Okay, so like this is x plus 7 times x plus 7. H minus 5 times h minus 5. 2x minus 3 times 2x minus 3. Okay, so do those. And if you want the answers, please, email me or, go to my office hours and I'll give them to you. Alright, let's go to the second thing. Okay. So now we're entering into the weird land of some funny little rules. Okay, so the product of a sum and a difference. Okay, so what this means is that, let's say A says A, so they both say A. So that means that these are both like the same thing, like these are both 5x, then, well, A times A is A squared, right? So this is 5x times 5x, you get 25x squared. Then if they both have, one has a plus sign and one has a minus sign, and then you have B, like there's B like this, these are both the same thing, like these are both 3y, these are both 3y, then you get, well, B squared. So then, now 3y times 3y is 9y squared. So what this means is if like the things on the left are the same thing, the things on the right are the same thing, there's a plus and a minus symbol, you really just get the A thing squared, you get the B thing squared, and there's nothing in the middle. There's no stuff in the middle like there was for the first one. Yeah, that's just the truth. It's kind of a shortcut rule. So again, you don't have to do, this is actually a lot quicker and easier than what you've been doing. So notice these are both 2x, these are both 1, there's a plus sign and a minus sign. So that means the answer is 4x squared minus 1. That's actually the answer. So this is the one and only time where you don't have to do the whole like stuff in the middle. I mean, you can, like, you really should, just so you kind of understand it. So like 2x times 1 is 2x. Negative 1 times 2x is negative 2x. 2x minus 2x is 0. So what's really happening in this is that the stuff in the middle turns into 0 every time with this rule, and you don't even have to write anything, right? So, like, some of these are a little weirder because they have, like, other things, other stuff. All right. So 8, 3 times 3 is 9. Both plus sign, minus sign, plus sign, both the same thing. Minus 25q squared. Notice there's always minus in the middle, and that's because, well, minus times a plus is a minus. And that's it, really. Yeah, try the other ones. This shouldn't be hard for you. Okay. Now, let's enter into the other side of polynomials, okay? So far all we've done is multiply, right? This was multiply, this is multiply. Well, welcome to factoring. Okay, so factoring really means dividing. It's kind of like dividing, but I don't tell you what you're dividing by. Instead, you're finding the factors of a polynomial. Okay, and we're going to start off with what's called the difference of squares. This is a fun little rule. It's a special little rule, and what it means is that all right, so you see a squared, and that has to be a perfect square. B squared also has to be a perfect square, and there has to be a minus symbol. And then what this becomes, like to factor it means like kind of breaking it apart, is that it is it turns into the square root of a squared minus the square root of b squared plus the square root of a squared, times the square root of a squared plus the square root of b squared. So, all right, for example, all right, factor each polynomial. All right, so n squared minus 64. N squared is a perfect square because the square root of n squared is n. 64 is also a perfect square, and that is, well, 8, right? And so n and 8, n and 8. And so that's just kind of what goes into the rule. So all you're really doing is plugging in the square roots of the things in the question into this rule. I think that makes it more simple. So yeah, it could be, this could have been the plus, and, this could have been the minus, and this could have been the plus. That doesn't really make any difference. All right, example 2 is like, well, what if neither of these things are perfect squares, but these actually have a common, greatest common factor of 2. These are both factorable by 2. And 25 and 36 are both perfect squares. Yeah, so this 50a squared minus 72, both 50 and 72 are divisible by 2. So now you have 2 times 25a squared minus 36. And then you should, then 25a squared is a perfect square. It is 5a. 36 is a perfect square. That is 6. So this becomes 2 times 5a plus 6 times 5a minus 6. Okay, I'm going to do a few of those with you. All right, first up, let's just start with an easy one. This is, okay, so again, it's always the square root, x squared is x. Let me just put that, okay, x, that goes here, right? All right, what's the square root of 81? It's 9, right? So there's a 9. There's a 9. And all that goes here is 1's a plus, and 1's a minus, and you're done. X plus 9 times x minus 9. Okay? So 11, both of those are perfect squares. 12, those are both perfect squares. 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 Okay. Now, 17 and 18 are not perfect squares. I want to do 18 with you. 17, I think you can figure out 17 based on what this example is. If you notice, they both use 50 and 72. I think you can figure that one out. All right, so 18, I'm going to do this one. Let's rewrite it, okay? In fact, I'm going to do that right now. Minus 2. Okay, now, notice both of these are divisible by 2, right? They're both divisible by 2. That creates x. Yeah, I don't want to, it's going to take me a while to make a little symbol. That's x squared minus 1, right? Okay, x squared minus 1 is, well, x squared is a perfect square. That's x. 1 is also a perfect square. That's 1. And plus 1. So 2 times x plus 1 times x minus 1 is the answer. Okay, so that's really all I would like to do for you. I'll do 16. 225 is 15 times 15 minus a, 15 plus a. And that's actually the answer for number 16, because 225 and a are both perfect squares. All right, that's it. Please try finishing the rest of this paper. The puzzle piece will make more sense. Please email me for questions. And that's it. Have a good rest of your day.